what you see up there, and just the thought of where we've come from and where we are now is absolutely astounding in all sorts of technology, but TV there particularly. That would have been pre-war in the US at that time, so yeah, it wasn't too bad for pre-war. As many of you know, most of the TV now in Australia and in the world is all high definition, and very little anything else. Although in Melbourne there's been a minor resurgence of some of the other stuff. The exception there, of course, is the IC905 that many of you have. Personally, look, I can understand that they probably didn't have enough memory to do too much else than what they did do, but to me, FM TV was a bit of a step backwards, but on the other hand, I've got my old FM TV exciter out, and we'll probably see what we can do with it just for fun. And we're doing the same with AM, believe it or not, as well. Again, that's about where we are in terms of everyone. We're not going up to the next level, at least not in the foreseeable future. What we see there is pretty much as far as you can go, and the evidence is that certainly the 4K stuff is brilliant when you look at a stationary picture, but the analysis has been done that once you get a moving picture, there's not too much difference between our standard high definition and the new 4K stuff. We've got the two standards that exist for television, one being the one that is for terrestrial and designed for multipath and all of those sorts of issues. And then we have the satellite protocol, which is very much designed for point-to-point. And pretty much all of the early adopters of amateur television digital was DVB-S for that reason. A little later, some people started using DVB-T, probably mainly because there was some commercial availability in terms of that technology. And it's very good technology that is available for that. However, what we find is that about 4 to 5 dB of penalty in terms of the difference between S and T. In other words, you're going to have to pedal a bit harder if you use DVB-T than DVB-S by about 4 or 5 dB. That's a very typical spectrum of DVB-T that many of us are familiar with. What's underpinning all of that is a whole lot of sidebands, many, because it's a very complex modulation system. And the spectrum analyzer hasn't got the capability of resolving what is actually there. So we have the what we call the BAREC head, which is DVB-T, and then we have the classical haystack, which is characteristics of DVB-S. But again, underneath that haystack, there's many signals, and the analyzer's not resolving them, that's all. Most of us are using QPSK modulation, which is quadrature phase shift keying. And it's really just 4 different phases governed by 2 binary bits. So that's the bottom level. We did try QAM16 for a while, particularly with repeater outputs. But going back to QPSK, we found that that was a better penetration in terms of coverage. So it's a simpler sort of modulation system. and things like QAM16, which is a combination of both phase and amplitude modulation together, starts to get a bit complicated, and the linearity requirements for that also. So we found that QPSK is really, you get high definition pictures, and it's the best modulation available for amateurs in our view. Most modulators can't just simply very easily select those 4 phases. So what the modulator is, what the source is, you have a Q set of digital data, you have an I set of digital data, and in a Cartesian graph format, if you've got a Q value and you've got an I value, then that specifies that phase point. So we have QI data streams, and there's an example of IQ, and then the signal that the IQ makes. The reason that you get the multiple sidebands is if you look at that bottom scale there, you can see that there's some pretty dramatic changes of phase happening. So as soon as you've got that, you've got basically a sinusoidal carrier that's got to move to a different shape. And in doing so, you generate lots and lots of extraneous signals or sideband signals associated with that. So that's the reason why you have that multiple set of signals being generated. And of course, that's a data stream that's happening at a very fast rate as well. So that's just an example. So what you need for an ATV transmitter, you've got to have an MPEG encoder, and MPEG is the standard protocol for encoding digital. You've got to have an IQ modulator, and you've got to have a Class A power amplifier. But what we're seeing now in the new developments is that all of the MPEG encoder stuff and the IQ modulator is being done in software totally, and that all you would need with some of these new systems is a reasonable sort of a computer that's got a HDMI port on it, not too hard to get, and then you still need the linear amplifiers. So that's just a very recent development. So we moved from like Neil over there and myself and John, we have very much hardware type modulators and systems, but it's evolving much towards a software system now. And the British Portsdown system was a move in that direction as well. We're also seeing some developments in terms of what SDRs can do as well. So things are moving in a very fast rate, as technology does anyway, I guess. There's a band plan for 70 SEMs, and pretty much all of those are used by the 3 ATV repeaters that are currently active in Australia, which is unfortunate really. There used to be an ATV repeater in Adelaide, there used to be one in Sydney, and there used to be one in Brisbane as well. The Brisbane one maybe will get back online sometime in the future. Sydney, I suspect, probably won't. There's nothing there that seems to be available. So it's one of those things. The interesting thing is we've got one at Port Pirie, and Port Pirie repeater is if you've been to Port Pirie, you'll know that there's this enormous bluff that overhangs Port Pirie, and their repeater is up on that bluff. And of course it sprays right across the bay. So there's the guys in Whyalla also that are involved in the Port Pirie repeater. So we've got a small group there in Port Pirie and in Whyalla, and they're very active. And in fact, Bevan VK5BD is one of the guys over there in Whyalla, and he does the ATV broadcast every Sunday. How the hell he does that, I don't know, but it's really worth watching if you haven't done it. And it was interesting to hear that the president of the WIA actually watches Bevan's production. It's on YouTube, but it's also on the 3 amateur TV repeaters as well. So that's a feature of Sunday, actually. 23CMZ, there's the channels that's available right now. That's very generous. We're hoping that we may be able to keep some parts of that. There's certainly some inhibitors that are around the satellite systems that are being developed, particularly in the northern hemisphere. I suspect down here in the southern hemisphere we mightn't be quite so effective, but we'll just have to see what happens with 23CMZ. And there's certainly a group of us in the WIA that are monitoring very closely what's going on there, and the WIA is very supportive of our activities, both the small signal stuff, satellite stuff and TV stuff. So I think our interests will be looked after there. But currently we've got those 4 channels, and in Melbourne we're using the 4 of them actually. That's what happens up down in Tasmania. They do transmit not from a repeater but from a transmitter that's located in their rooms. And those of you that have been down to Tasmania will know that their rooms are very well situated and overlooking Hobart. So that transmission would be well received all around Hobart, and they do it quite regularly. So that's great. Here in Bendigo, there's the Bendigo ATV repeater. It runs 10 watts on 400 megs. And that's vertically polarised, and you can see what the input frequency is there. And it takes DVT only though at the moment. I'm not sure whether S will arrive, but that's the situation for Bendigo. And the broadcast is seen on RBO every Sunday. The Melbourne ATV repeater, which I'm more familiar with, significantly 100 watts out there on DVB-T2. In fact, that's a technology, the second generation of terrestrial, and I'm pretty sure that the commercials did just do some experiments with T2, but in fact they're only running DVT at the moment, so that's a little thing for us, I guess. The other thing is that there's 2 multiplex channels with RTV. There's RTV1 and RTV2. So in that 7 meg bandwidth that's available, we have 2 channels. And really, the east of Melbourne is RTV1, and the west of Melbourne is RTV2. And there's a bit of jovial jostling between RTV1 and RTV2 at times, which is good. We also have the advantage of having a fibre to the shack there, so we've got a very good NBN access for all sorts of activities. And we have SRT, which is well, it's not exactly a new technology now, but it's called Secure Reliable Transport, and it's an amazing technology that enables you to send high definition pictures via the usual internet channels. So when we have our annual DATV QSO party, which we do every August, we have our friends from the US coming in direct. We also have our friends from the UK coming in direct. And that particular activity of last year was significant because we had the people in the UK were working through the Q0100 satellite, then bringing the pictures back from the satellite, piping them back to us via SRT, and then we transmitted them all over Melbourne. And then we also had YouTube running, and that of course went internationally as well. So that was a great feature of last year's the ATV QSO party, which I hope will continue this year as well. There's the operational frequencies for RTV, as I mentioned, and another feature of RTV is we do have DVB-S and DVB-T both, and partly because that's where we started with S, and we moved on to T to include the new modulators that were available and some other techniques. And there's the rack for RTV that you can see there. And down the bottom there we've got a very lumpy 500 watt PA. With all PAs, because of the linearity requirements for TV, you need that kind of power to run a good 100 watts. So you need that elbow room. So whilst it's a 500 watt PA, it's actually 100 watts out. And the same would be exactly for Port Pirie. They have a 500 watt PA there as well, but we run 100 watts to get the linearity there. And you can see the two controllers there. We've got RTV1 controller and RTV2 controller as well. That's a bit of a block diagram of how we do it. And how we do it was developed gradually. And the whole system has grown piecemeal, but at the end of the day we had one of our guys suggest that we could get DVB-T and DVB-S both using a single receiver, and that's what we do. We use what's called a combo receiver, and the combo receiver has a satellite tuner in it, but it also has a domestic DVB-T tuner in it. So what we do is we bring the signal right through to a 3 dB coupler. That 3 dB coupler then splits the incoming signal. One signal goes to the satellite port, and the other part goes to a down converter, because we're on 23 CEMZ and we need to get down into the broadcast band because that's where the DVB-T tuner is. And we down convert to channel 29. So it's instantaneous, and then we have a controller that polls between the two ports. We load the satellite system into channel 1 of the receiver, and we load the channel 29 into channel 2 of the receiver. And then we just simply poll between 1 and 2, 1 and 2, looking for an S signal or looking for a T signal. And then that goes into a HDMI switch and then onwards. That's how we did it, or I guess how I did it. We got inside the receiver and we actually broke the IR line, and then there's a little pickaxe there, and the pickaxe generates the channel 1 code, the channel 2 code for polling. It's also looking for a key signal which comes from the receive lead, and that then keys the transmitter on. So it's a fairly simple execution of a great idea, and the idea of the combo came from Rob 3TRX, and we're able to execute that. We can bring up a signal report. That's very popular. Again, that's just talking to the little pickaxe and saying, well, yeah, bring up the signal report that's embedded into the receiver, so people can see how they're doing. They can direct beams, etc. So we often see those coming up at various times. I see Neil fairly regularly checking how he's going with that. We now move on to Port Pirie, and as I mentioned, they've got 100 watts. And I forgot to mention that RTV's got 4 antennas, 4 panels that are looking in the 4 service areas for RTV. So that accommodates the 4 channels that we've got on 23SEM. But 5RDC is on the bluff at Port Pirie. I've flown over it a couple of times, so it's a magnificent site for a repeater. And they have a grid antenna that's looking down towards Port Pirie, and then they have a grid antenna that's looking across to Whyalla. And they also run 100 watts from a pallet, but it's a 500 watt transmitter. So that's their system. I can't really give you much more detail about how it all happens there, but it's fairly complex, like RTV is as well. And it certainly has a whole lot of control systems that are embedded there, and I know you can't read that, but Bevan sent that across to me, and I put it up there because I was amazed at what they've got there, that they can call up under all sorts of stuff. He did tell me that mainly it isn't used, but at least it's there, I guess, and it's of interest. Okay, let's just have a quick look at what transmitters you might need to get onto ATV. A lot of people are using OBS, and OBS is a free software program that you can load, and if you've got a HDMI dongle like I've got there into a USB, you can then feed your camera, or you can feed directly as well into this, and it's a fairly complex switching system, and lots of people are using it. The other option is vMix, which is also very good, but you've got to pay for that. So amateurs being amateurs, most people are using OBS. The other option, or as well, you can use the very excellent ATM switches. ATM was a commercial company manufacturing for the commercial industry, but they decided they'd package their HDMI switcher into smaller units, and in fact that's industry standard HDMI switching. They were fairly expensive initially, but I think that the prices of those is coming down. So that's another option. This is the British system called the Portsdown, and what you see there is a 7-inch touchscreen, and behind that is a Raspberry Pi, and then behind that is a guy in England who's an absolute software guru, and he writes the software for the Portsdown. We get regular updates, and there's all sorts of tricky stuff inside the Portsdown. For example, I could go online right now and control my Portsdown online, because I can actually get that very same picture on my PC and use a mouse and transmit. So it can be a web-based thing, and in fact, one of the options is to run it as a web base. The ATEM as well, you can run on your local area network. So you can have the Portsdown on your local area network as well. You can have the ATEM on your local area network, so you can have it remote controlled. The Portsdown is very, very popular. It can be a little bit clicky to get going, but once it's there, it's very reliable. The big advantage of the Portsdown is that it will do DVB-S, it will do DVB-T, but it will also do narrowband. And when we're talking about narrowband, we're talking about very low data rates, relatively anyway, and that means smaller bandwidths. So it would be possible, and I believe that it is possible to put ports down up on 6 metres, for example, and I do have a 6 metre option for that. Haven't made any contacts on it yet, but that's the kind of bandwidth that you can get down to with the ports down, which is one of its big features. And we do run cross-town stuff, point to point, using our ports downs as well. I've seen Neil, 3 BCU, cross town, where on 23CMZ I wouldn't have a prayer of seeing him. But on narrowband, of course, your power is into a smaller bandwidth, and therefore you're more likely to be successful. So that's a very, very powerful system. There's lots of stuff embedded inside the ports down. That's just a picture of the thing, but it's not really up to date. The DATV Express was an American board that's no longer available. The Lime certainly is still available, the Lime SDR, although it's very expensive. And one of the guys in Melbourne has got hold of some old, well, they're not old, but they're either second-sourced Plutos. They're not Plutos in a case and all that, but it's the PCB. And it's Joe, 3TET, and he's got ports down running with, no, not ports, he's got that running with the Pluto that he gets from somewhere. I'm not quite sure where, but he gets them anyway. And he's got some software that runs with that. So that's significant, because we're talking of just maybe $300 up for a whole system there. So if you're interested in that, you might contact Joe, 3 Tango Echo Tango. I'm sure he'll answer questions about his Pluto and the way he's gone about it. That's just an example of one of the little things that's inside the ports down. There's a spectrum analyzer there, so you can actually look at your signal or other signals that are coming in. And there's lots of other things that are embedded, like there's a signal generator there, etc. That's another option for a DVB-T transmitter, where you use a commercial modulator that you get, that, you know, the things that are used for distributing TV around a building, something like that, and then you simply use an up converter to 23CMZ, and that's a very cheap way of getting a DVB-T transmitter. And there's an example there. We've got a mixer that you get off the internet already there. You can buy the little oscillators. They're absolutely wonderful, that run up to 2 or 3 gigs, and very stable. And it's really just a matter of assembly of that system. There, in mine, I've got a couple of other little things, like I made a little bandpass filter there, I can see, and there's a couple of mini kits preamps there. So that's a very cheap way of getting a T transmitter. That's another option. That's a bit more expensive, but very, very good. They're hides. They're based in Taiwan, and they are very, very customer focused. So if you contact hides in Taiwan, you'll talk by email to somebody, and they're very responsive to all the questions that you might have. And for those of us that have bought their transmitters, they do get regular updates, and you send an email to the guys at Hides, and if it's 24 hours, that'll be tops for a response. So they're very, very customer focused. A little bit on the expensive side, perhaps, but it's a one-stop shop. You can see there I've just got the Hides transmitter. I've taken the back and front off the thing for a little bit of cooling, and then there's just a PHA1, which is a little